Hello everyone, thank you for having us. I'm Widya Ramadhani with my friend Dimas Listiono from Chemical Engineering 11 Maret University. Today we are going to present our research about microwave-assisted in synthesis of Cassava Bagasse-Acrylamide-Carrageenan bead gel. This is what our research looking at, so let's get started.
The exciting hydrogel are derived from synthetic polymer, and most are known is to be toxic to the environment due to non-degradability and non-biocompatibility. It is necessary to develop eco-friendly hydrogel, especially natural material such as cellulose. Cassava bagasse come from cassava production. Leftover cassava bagasse can cause air pollution, even though the cellulose content is relatively high, namely 65.9%, and potential to form hydrogel. The conventional synthesis of hydrogel method is yet to be developed due to energy, time, and reaction component saving. Thus, this work chooses the grafting method with microwave irradiation by utilizing cassava bagasse as a backbone, grafted with acrylamide and mixed with carrageenan to produce bead gel and improve swelling capacity. So, the aim of this research are to determine the ability of cassava bagasse to form bead gel, to study the effect of cassava bagasse-acrylamide weight ratio and the grafting duration time on the swelling capacity of the bead gel produced.
The method consists of 4 steps. First, preparation of cassava bagasse. Cassava bagasse was put into a beaker glass and stirred with an adhexane solvent for 24 hours. The beaker was covered with aluminum foil. After draining, the cassava bagasse was dried in an oven. Second, microwave-assisted in synthesis of cassava bagasse-acrylamide. The acrylamide solution was added to the cassava bagasse solution and stirred until homogeneous. Afterward, the solution were put into a microwave. Microwave irradiation ran at 700 watts with grafting reaction times of 205 seconds and 480 seconds. The mixture was allowed to stand for 24 hours to complete the grafting reaction time. Then the grafting reaction time was terminated by adding 5% weight per volume saturated hydroquinone solutions. The mixture was stirred and allowed to stand to precipitate. The liquid phase at the top was taken and the solid phase was added with excess acetone. The solids were dried in an oven. Third, preparation of bead gel cassava Bagasse-Carrageenan. The bead gels were made by mixing the grafted cassava Bagasse-Carrageenan in a 1:1 weight ratio. The mixture was put in distilled water, heated to 85 degrees Celsius, and stirred until the solution was homogeneous. The solution was injected into a palm oil layer and then dropped to 0.2 molar kalium chloride and 0.2 molar calcium chloride mixture aqueous. The obtained bead gels were filtered and immersed in ethanol solution for 4 hours. Last, determination of the swelling capacity of bead gel. The sample was soaked in a distilled water and weighed every 30 minutes to a constant weight. The swelling test of the bead gel sample was carried out by soaking several beads of uniform size into distilled water for 2.5 hours. The distilled water will diffuse into the bead gel.
The swelling capacity was calculated by using this equation as shown in this slide, where My expressed as weight weight, MD expressed as dry weight. It can be seen in this figure the appearance of bead gel before and after being immersed in water. This slide shows the code of sample. A is for cassava Bagasse-Acrylamide weight ratio 1:5 and a grafting duration at 205 seconds. A star is for cassava Bagasse-Acrylamide weight ratio 1:10 and a grafting duration time at 205 seconds. B is for Cassava Bagasse-Acrylamide weight ratio 1 to 5 and a grafting reaction time 418 seconds. And NG is for Cassava Bagasse without grafting step.
And now we talk about the result. The grafting process was kept at the temperature of 65 until 70 degrees Celsius to minimize the formation of competing homopolymers and prevent unwanted vapors, which may be toxic to the acrylamide. The output temperature produced during the cooling cycle at the grafting reaction times of 205 seconds and 480 seconds is shown in the following figure. This is the figure of grafting output temperature on 205 seconds. Meanwhile, this is the figure of grafting output temperature on 480 seconds. It can be seen that the longer the grafting reaction time was carried out, the average cooling cycle temperature increased. High temperatures will damage the structure of the polysaccharide backbone and reduce the effectiveness of the resulting graft. So, bed gels can be synthesized from Cassava Bagasse-Acrylamide-Carrageenan with microwave-assisted. The success of grafting is proven if the swelling capacity has a higher value compared to the production of bed gel without grafting step. It can be seen from this figure that bed gel have a perfect granular shape. This table shows the appearance of bed gel before and after being immersed in water. The number in code indicated the repetition of swelling tests of each the same weight ratio of Cassava Bagasse-Carrageenan. The colors were getting brighter and transparent, while the size is getting bigger. The differences in shape and size of the bed gels produced can cause a difference in surface area of the bed gel, which affects its ability to swell. It can be seen from this table. At a constant grafting reaction time, bed gel A star had a higher swelling capacity than bed gel A. The increase in swelling capacity may be caused by the availability of more acrylamide monomers. During irradiation, the hydroxyl groups in acrylamide become active. Thus, polymerization can occur into polyacrylamide. Also, during irradiation, the hydroxyl groups in the cellulose become active too, and then the active polyacrylamide binds to the active cellulose.
Effect of microwave retention time on bed gel swelling. So from this figure, it can be seen that at the same weight ratio of Cassava Bagasse-Acrylamide, the variation of grafting reaction time doesn't significantly affect the swelling capacity. However, it affects the grafting output temperature. In general, the conclusion of this research divide into three parts. First, bed gel can be synthesized from Cassava Bagasse-Acrylamide-Carrageenan with microwave-assisted. Also, the variation of weight ratio of Cassava Bagasse-Acrylamide affects the swelling capacity on the bed gel produced. The higher weight ratio of acrylamide added, the more swelling capacity obtained. Last, the variation of grafting reaction time doesn't significantly affect the swelling capacity. And that brings us to the end. I would like to thank you for your time and your attention. See you next time.